Greetings and welcome to the basement. In this video, we are going to answer the eternal question. Why did the chicken cross the road? Answer: because I didn't want to do this with cubes floating in space. The actual question we are going to address in this video is how do you move an object in Unity? Now, the principles are the same whether you're operating in 2D or 3D space. You just are obviously cutting out one of the axes in movement. And so I'm just going to focus on moving in 3D space here. Now, I have a couple of assumptions going into this video. Assumption number one, you have a basic understanding of the Unity editor. Understanding number two, you have a basic understanding of how to add and remove components to a game object and use the inspector to modify the properties of those components. And finally, that you have a very basic understanding of the C# programming language. I will not be going over basic syntax. So with that out of the way, how do we deal with getting our chicken to move? Because I do, in fact, want my chicken to cross the road because I want him to gain access to these lovely little bushes over here because I don't know, chickens like lavender flowers? I don't know. This particular chicken likes lavender flowers. He wants to cross the road to get to the lavender flowers. Now, there are a lot of different ways that we can make game objects move in Unity. I am going to be covering the most basic method of directly controlling the game object. So I'm just going to directly manipulate this chicken's position and over time, move it over here. Now, before we start that, we need to talk a moment about orientation and what does forward mean. In the context of Unity, when I refer to something's forward vector, I'm referring to the local vector that points from a local orientation that points into the positive z, which in the case of Unity widget is the blue arrow. So this blue arrow is pointing forward, or pointing this direction. So this would be forward for Unity. Moving in this direction would be backward, and everything is based relative to that. So if I want to move up, it'd be positive y. And if I want to move to the right, keep in mind this orientation here, if this is forward, this would be to my right, and moving left would be in the negative x. Now, you will not always see the translation widgets in this orientation. You could also potentially see them in global orientation, in which case, as you can see here, the forward, in this case, the positive z is not really pointing in the direction that the chicken is looking. The chicken is looking someplace else. And in fact, I can make that even more drastic by rotating the chicken. Now the chicken's looking more right than it is forward. And that has to deal, again, with whether or not your widget is in global or local mode. And that's also important to understand when you are moving a game object in Unity is, are you moving things in global space or are you moving things in local space? Are you doing global or local referencing? You always have to keep this in mind. Now, I am going to be dealing specifically with global when I am doing the code. Because when I refer to a transforms forward vector, it is going to give me this forward vector here in global space. So that is why I'm going to be using global manipulations. Of course, I now need to undo that because I want my chicken walking this way. Well, let's get a component on here. Now, obviously, there is no default component for moving a character forward, so we are going to have to create our own. I prefer, especially when I know I'm creating a new script component that I know has to go on a specific object, I prefer to use add component here. But of course, you could right-click, create a C# script and add the component, drag the component on. But like I said, I'm going to do add component through this menu here. I'm going to call this chicken move. I would always recommend that your custom components start with a capital capital letter, and use this naming pattern. It is a very widely accepted convention. There we go. I now have my chicken move script, so I will double click on it to open it up in Visual Studio. I'm using the slightly older version of Visual Studio, but that should not impact anything. And here we go. Now I am going to want to control how fast this chicken moves. And so to do that, I'm going to put in a public float move speed. And I'll initially set it to 5. And I should also probably put a note in here to remind myself units per second. That is something else that is very important to keep in mind when we are moving objects around and specifying speeds for them. What is the unit of our speed? Is this per frame, per second, per minute? What is this unit? I would recommend that you always think of your speed in terms of units per second. So I am saying over the course of 1 second, this chicken should move 5 Unity units. Obviously, these numbers are going to vary drastically depending on the style of game, how far back the camera is, the scale of the game, and a whole host of other factors. I want to make this public because I definitely do not want to have to be coming into code to modify this value as I'm tweaking things. So I want to make sure that this shows up in my inspector. I am not going to be using start in this particular example, so I am going to get rid of it. It does not hurt to leave start in if you are not using it, and it obviously doesn't hurt if you take it out if you are not using it. Now, an update is where all the magic happens. As it says, update is called once per frame, so any operation, including movement, that has to be handled on a per frame basis needs to go in update. That does not mean that the code literally has to be an update. If you want, you can declare a custom method and call that from someplace else. Go ahead and have all the code here. This all works just as long as it's being called from within update. Of course, we don't need to get fancy. This particular example, I'm just going to have everything in update. Now, I want this chicken to move forward. Under the transform property, which every game object has to have a transform by definition, you have a variety of reference vectors. We have forward, we have right, and we have up. Notice we do not have left, we do not have down, and we do not have backwards, simply because those vectors would just be the inverse of others. So if I wanted to move backwards, I would use the forward reference and invert it with a negative sign, and that would give me the backward vector. So what do I need to do? I need to get my direction. I need to scale my direction by speed. And then I need to add this offset to my position. These first two actions here are basically calculating an offset. In other words, how much, in what direction should I move this game object? And then once I determine that offset, I need to add it in. So since that's what I am calculating, I am going to declare a vector3 offset. And I will initially set this to my transform's forward vector. So the transform always knows what its forward vector it is in global space. And so I will grab that. But now this is going to give me what's called a unit vector, a vector with length 1. So if I just used that, I would literally just be moving 1 unit forward per frame, which is definitely not what I want. So I need to scale that. I'm going to scale this. I'm going to say offset equals, or I could have used times equals as well, offset times move speed. So now I'm moving 5 units. But if I leave it like this, I'm going to be moving 5 units per frame, which is not what I want. And in fact, I'm going to leave it like that for the moment, just so we can see what this kind of error looks like. Now that I have calculated my offset, I need to add that offset to my position and transform. So I will say transform dot position plus equals, or I could use equals. Either way works. Offset. This is just a little bit faster. Honestly, in this line here, I'm going to be removing. These two lines of code do exactly the same thing, just one's a little bit shorter. Let's see what kind of absurdity this gets us. So we have our chicken. We're going to hit the run button. And zoom, that chicken is gone. Where is the chicken right now? Let's go back over to our scene view. And oh my. Chicken is out of here. He is about, it looks like 5-ish kilometers away, maybe longer, because we got 4 kilometers on the Z and 2 kilometers on the X. Yeah, no, that is obviously not what we want. Not in the slightest. And that's what I mean by this is moving it per frame. So in order to correct that back to per seconds, I need to know what fraction of a second has it been since the last time update was called. And so to do that, I can scale this by time.deltatime. Time.deltatime is a phenomenally useful piece of timing information that Unity provides you. As I said, it basically represents what fraction of a second has elapsed since the last time we called update. So anytime I need to try to figure out like a timer or moving something in units per second or anything involving seconds that's in the update loop, I'm probably going to have time.deltatime in there someplace. Now, because of that time.deltatime, we will be moving 5 units per second, which is what I want. There we go. He's still a speedy little chicken. But at least that's more reasonable. If I wanted to slow down the chicken, maybe chickens shouldn't move quite that fast. Maybe I want to have my move speed at 1. Hit the play button. That seems to be a bit more of a sedate pace for a chicken. Now, notice a couple of things that this chicken is doing. And in fact, I can probably make it more clear by repositioning the chicken. Excuse me. And then hitting run. Off the chicken goes on his leisurely saunter, and apparently he's a ghost chicken because he just goes right through the wall of the house and just keeps on going. When you are moving a game object like this, when you are directly manipulating a game object's position, it does not care about collisions, solid volumes, or anything else. It's going to move to the position that you specified. This is also why, as a side note, you should never do this in combination with, say, a physics system, because physics will also be attempting to manipulate the object's position. And if you are trying to also manipulate the object's position, twitchy behavior incoming. So we would never want to do something like this if I was also trying to have the object controlled by physics. But that's quite a bit beyond the scope of what I want to cover in this video. So let's continue on with taking a look at moving the object. Now, if I wanted to say have the chicken move to the right instead of moving forward, I could just simply replace this with using the right vector. And sure enough, now our chicken is sliding off to the right. But I do, in fact, want my chicken moving forward. And let's fix his orientation so he's once again looking at the tasty bushes. Now, another thing that the chicken is doing is the chicken is not stopping once it reaches the bushes. I have a saying when it comes to computers. Computers are phenomenally stupid. They do precisely what you tell them to do. My code has told the chicken to move. It has not told the chicken to stop. So I need to get the chicken to a specific point. Well, how would I go about doing that? Well, a very useful way of doing things like this is to use empty game objects. So I am going to create an empty game object, Control-Shift-N, right-click, create empty, whatever way you want to do it. I'm going to take this game object. First, I'm going to move it by using snap to contact to make sure that this empty game object is on the surface of the terrain. Now, I also need to pay attention here to pivot points. In this particular case, my chicken's pivot point is right on the bottom of his feet. So this will work out just fine. Actually, I can raise the chicken up here a little bit. So the chicken's going to walk across to where this empty game object is and stop right there. And so I don't lose track of it, I am going to change it so that I have a little green diamond showing me where this game object is. So the chicken's going to walk to where its pivot's going to match here. Let's call this move target. Never underestimate the power of empty game objects. They are phenomenally useful. Now I'm going to need a new property for my chicken. I am going to need a public, not float, transform, move target. And I'm going to change this code. So I'm actually going to remove this code. Into its own method, just in case we want to go back and use this. All right, so I want to get my chicken's position to this move target's position. Now, if I want the chicken to actually look like it's moving, what I don't want to do is I don't want to say the this is optional. I prefer using the this in situations like this just to be very explicitly clear as to which transform I'm talking about here. So this dot transform dot position is going to equal to my move target dot position. I would not want to do this. Again, not unless my intent is to have my chicken teleport. Because what's going to happen, as soon as I hit the play button, chicken's going to be there. Assuming that I actually remember to hook up my target. Always important to remember to hook up your variables. Now, when I hit the play button, doink, teleporting chicken. You should always check your console, by the way, for errors. For some reason, I've got this invalid editor fallback error window popping up quite a bit. But anytime you see an error in there, you should always check it. So for example, when I had goofed up and I had that move target as none, when I hit the run and the chicken doesn't move, again, not entirely sure why I keep getting this editor error here. But there we go. That's the more helpful error message informing me that, yeah, you have a no reference exception. Almost always, not guaranteed, but a lot of the times, when you see one of these messages, it means that you have forgotten to hook something up. But I don't want my chicken to teleport to that location. I want my chicken to walk over there like the chicken was doing previously. So how can I do this? Now, again, there's a lot of different ways of doing this. I have, and I'm going to show the most basic version. I have a starting position. I have a target position. So what I can do here is I can calculate, well, what is that direction? I've got two vectors. I've got 2 points in space. How do I determine a vector that points from A to B? Well, I can say vector 3, move direction. Now, this time, oh yeah, let's still call it an offset, because at the end of the day, this is what I'm going to be calculating. I'm still going to be calculating an offset. And this time for my direction, just like I have down here, get the direction, it's going to be a couple of extra steps. So first I'm going to say move target minus, move target dot position minus transform dot position. So I am getting a vector that points, remember when you do A minus B, when it comes to vectors, you are getting a vector that points from B to A. So I want a vector that points from my current position to where I want it to be. Now, this vector is not going to be a unit vector. It is going to have magnitude because it is literally giving me the vector that exists between this point in space and this point in space. So there is magnitude, there is length here that I do not want. So I need to do what's called normalizing. So I need to normalize the vector. So that way now it's a unit vector. The vector has a length of 1. Now that the vector has a length of 1, I can scale it by my speed and by time.deltatime. So I can say offset equals offset times move speed times time.deltatime. Oops, that's not the right delta time. Thank you very much. There's another step we have to put in here, but for the moment, let's just verify that the movement is working like we would expect. So I am going to say transform.position plus equals offset. Now this time it's going to work a little bit different. Regardless of where our chicken happens to be, he's going to slide towards that point, or at least he should. So we'll hop back over to Unity, let things recompile. And off he goes. Now, something a little bit odd is going to happen once he gets over there. Or not. He'll just stay still. I was actually expecting him to jitter a little bit. I guess once the distance gets perfect, it doesn't jitter. And there he goes, sliding in from the side there, and sticks the landing. Let me increase his speed a little bit, because I think that will cause him to jitter. There we go. See how the chicken's twitching a little bit now. And the jitter will get even worse the higher his speed goes up. Kind of seemed to have just teleported there because, he's moving at 15 units per second. And now the chicken's just like really just jittering back and forth. But if he's moving at a nice sedate pace of 1, then he doesn't jitter. This is another important aspect of game development. Sometimes certain bugs won't manifest themselves until the numbers are just right. And the reason for this is once we get close enough, if we're moving slow enough and we're close enough, basically the offset will become 0. But if we're moving fast enough, we'll overshoot our target position by just a little bit. And then we will, on the next frame, I was like, oh, okay, we've shot past, so now we need to go back in the other direction. And we'll shoot past again. Oh, next frame, I need to go, and it will just keep just ping-ponging back and forth. So we need a little bit more logic here. This will be the last bit that we do for this very basic movement, because this video is getting a bit long in the tooth, is we need to detect how close are we. So when we come here and we do this calculation right here, we're going to have magnitude. In other words, distance. How long is this vector? And so we should probably say something along the lines of, well, if, I only need to get so close to this. And so let's say if this vector is less than half a unit, then I don't need to do anything. Or more specifically, as long as we're more than half a unit away, I want to move. So I can ask if offset dot magnitude, of course, magnitude is the length of a vector, if the magnitude is greater than 0.5f, remember when you do hard numbers like this, you do have to include the f. Otherwise, C# assumes doubles, and it will generally yell at you if you don't have the f in. So if it has a magnitude greater than 0.5, then I will do these actions. Otherwise, if the magnitude is less than 0.5, I won't do those actions. Again, I'll set my speed back up to 6 since that actually had the jitter to it. And yay, no jitter this time. Crank the speed up to 15. Now at some point, the chicken will move so fast that the jitter will return. And that will just simply be a function of how accurate do I want to actually have it moving. You know, if the chicken's moving at a speed of 100 units per second, then yeah, probably checking that I'm within a half unit of my targets. Well, that worked okay. He's a little bit further in, so there's a bit more error there, but that is to be expected moving that fast. And with that, let's just hop over real quick and see this working in a very basic scene. Just to drive home the fact that, yeah, you don't need to do experimenting around with moving objects, excuse me, in a complex scene. So all I have here is a cube floating in space. I'm going to take my camera and use Control-Shift-F or align with view to align my camera's view to my editor view. And then I can take this cube and I can attach my script. So we'll attach the chicken move script to it. Now it is wanting to have a target. So I will create a sphere. Move it out into the world. Let me scale it down a little bit. So that way when the cube moves onto it, it just completely overrides it. Tell the cube, yes, I want you to move to the sphere. Hit the run button. And off it goes. Or if I wanted the cube to just move straight forward, and off it goes. So as a quick recap, transform.forward always refers to the local forward vector. So if you come into Unity, make sure that you are on local, select a game object, and turn on the translation widget. The blue arrow pointing forward, well, the blue arrow points in the direction of what forward happens to mean to that game object. So we can use forward to move things, well, in a straight line. Otherwise, I need to come up with some other way of calculating the direction, which in this case here is taking my start position and my end position and getting a vector that points from start to end. And then using that to move me in that direction until I get close enough. And what close enough happens to mean is going to vary immensely. Now, as I said at the start of this, There are a lot of different ways of moving things in 3D space. We could use physics to move it. We could use the character controller. We could use lerp for smooth start and slow downs as I approach a spot. There are a lot of different ways that we can move things in 3D space, but at its most basic core level, this is how you can do it. If this video has been helpful to you, well, then I would appreciate a thumbs up down below. And if this hasn't really helped you at all and left you more confused than you started, well, the dislike button is right next to it. Until next time.